Hi, we're going to go ahead and let's keep going. We're going to do an example. So, example of hypothesis testing. Here's our first example for z-test. A college football coach thought his players could bench press a mean weight of 275 pounds. It is known that the standard deviation is 55. Three of his players thought that the mean weight was less than that amount. They asked 30 of their teammates for the estimated maximum lift on the bench press exercise and found the sample mean to be 266 pounds and a standard deviation of 57 pounds. Conduct a hypothesis testing using a 0.05 level of significance to determine if the bench press mean is less than 275 pounds. So, there's a lot of information in that question, and we just need to break it down, and that's what we're going to do in the next couple of slides. So the first thing, why is this a z-test? And it's a z-test because we know because of the population standard deviation. And for this one, it's 55. And how do I know it's 55? Well, the college football coach already knew that there was a mean weight of 275 pounds and the standard deviation was 55. So that means that's his population. Additionally, when we go start talking about the other standard deviation in the problem, it really is about the sample because there's 30 teammates who have their maximum lift, which is sample mean of 266, which had a standard deviation of 57. So that's how I know this is a z-test problem because of that population standard deviation. State the null in the alternative hypothesis. Since I want to know if it's less than, I need to put the less than sign in the alternative. And it might be easier for you again to start with the alternative, that the mean is less than 275 pounds. So the flip side of that is the null is greater than or equal to 275. Is it a right-tailed, left-tailed, or two-tailed test? It's a left-tailed test because it's a less than sign in the alternative. Is the population standard deviation known? And if so, what is it? As we said before on that first question, we know it's a z-test because it had the population standard deviation, and the population standard deviation is 55. So now I need to calculate the sample mean, which I'm already given it, it's 266, the sample standard deviation, which is 57, and then sample size, which is 30. So here again is the instructions for the calculator. So I'm going to show you what it looks like in the calculator. So here in the calculator, I have stats, 275, population standard deviation is 55, sample mean is 266, sample size is 30, and again, I've got to choose my alternative hypothesis. So when I do it, I get a z-test output where it has the mean is less than 275. Again, that's my hypothesis. That's my alternative hypothesis. So you always want to check that. My z-score is negative 0.89627. I'm going to round up to be negative 0.90. P-value is 0.1850. Sample mean is 266 and sample size is 30. If I'm using the website, again, here's the directions, but this is what I'm going to put in. Because I have no data for this website, it was given to me in the problem. So when I'm saying no data, I mean it has an actual set of data that you put in and get stuff from that. We don't have that. And you'll know them because it's a list of data and it'll say, here's the data, this is what you need to use. So my population mean is 275. My population variance is 3025. Again, that's when you take that population standard deviation and you square it. My sample mean is 266 and my sample size is 300. Okay, I don't have any room here for my sample standard deviation, and that's okay. I don't need it because I have that population standard deviation, or in this case, the population variance. Level of significance was 0.05, and I'm running a one-tailed test because it was a less than. So when I do that, this is what I get. I get down here at the bottom, I get my z-score is negative 0.89627. That's almost the exact same from the calculator, and my p-value is 18406. Basically the same as what was from the calculator, okay? So find your z-test statistic and your p-value. And again, I showed you where I got those on both of them. So at the 0.05, what is my verdict? P versus my alpha. So my 0.18 is greater than my level of significance. Based on that decision, I'm going to fail to reject my null. So what was the reason for my decision? Because P was larger than the level of significance. So because P is larger than the level of significance, you fail to reject your null, which means you're keeping your null. So that means my null where the mean is greater than or equal to 275 pounds is found to be true. On the flip side of that, my alternative, the mean is less than 275, is found to be false. So for my conclusion, at the 5% level of significance, the true mean weight lifted is not less than 275 pounds. Well, you're probably thinking, well, you found your null to be true. Why didn't you conclude on your null? I'm going to conclude on the question I originally asked. And remember, the football players thought the mean weight was less than 275. Well, I didn't find that. I found that it wasn't less than 275, so I just need to conclude that way. And that's how you see that. At the 5% level of significance, the true mean weight lifted is not less than 275. What does that mean? It means that the mean weight was either equal to or greater than. And you're probably looking at the data going, but it was less than that sample. Yeah, but it all has to do with the population standard deviation. It has to do with how the data is spread out in the population compared to how the data is in that sample.